One of the most important things we do in chemistry is take measurements. In any laboratory science, really, we're taking measurements. Now, the measurements we take in a chemistry laboratory are very specific. They're done with what are called SI units. Now, SI stands for Système International. It's French. It's the International System of Units, and it's basically a modified metric system. So you have base units, which is length, mass, time, temperature, and volume. Now, the units I have on the left are a little different from the units that you see in the graph, and that's because for chemists, we're generally talking about grams, and we're generally measuring things in Celsius. But when we talk about the base units, what's considered the base units, for length, it's the meter. For mass, it's the kilogram. For time, it's the second. For temperature, it's Kelvin. And then you have derived units like volume, which is the liter. So volume is length cubed, right? So length cubed gives you volume. So liters would be considered a derived unit. But you can get every single unit that we talk about from starting with the base units. So your derived units are things like frequency, which is 1 over seconds, energy, which we're going to talk about a lot, which is the joule, which is newtons times meters. And if you look at newtons, that's a measure of force, which is meters times kilograms times seconds to the minus 2, right? So you can have a derived unit of a derived unit. Technically, Celsius is a derived unit since you start with Kelvin and you add 273. But these are the units that we're using. So the units that we use in America, it's not technically imperial. It's like American Standard Unit or U.S. Standard Unit or something like that. But we're and people are like, oh, we use the metric system. We don't technically use the metric system. We use the International System of Units, or SI units. So you should be familiar with the ones that you're most commonly going to be using, which is going to be stuff like meters, grams, seconds, and liters, milliliters, things like that. Now, when we're doing chemistry, we're working with all sorts of scales, right? You can think about stuff on an industrial level or stuff that you're doing in the lab on a much smaller scale. And so in order to talk about things at different scales, we use Greek prefixes. Now, these Greek prefixes basically multiply your base unit by a factor of 10. And so here's a list of them. This is not all of them, but this is a fairly comprehensive list. And one pattern that you see that there are two exceptions to, or a couple exceptions to, are that the really, really big numbers, the positive powers of 10, the very large positive powers of 10, those are going to be capital letters, whereas the negative powers of 10 are all lowercase letters. Now, you do see a few exceptions here in that the symbol for kilo is a lowercase k, and that's because capital K is Kelvin and things like that. But basically what you do is you say, okay, if I have a kilogram, I have 10 to the third grams. If I have a centimeter, I have 10 to the minus 2 meters. That micro there is the Greek letter mu, because M is milli, so they needed another M. But when you think about it, so a megabyte, right, or megahertz, that's a million. Micrometer is a millionth of a meter. Nano, things like that. You should probably know most of these off the top of your head. The ones that come up a lot are kilo, centi for centimeter, milli, micro, and nano. Those are the ones that are generally going to come up the most. But what is important about this is that, we can set up equivalences. 1 kilometer is equal to 10 to the third meters. 1 milliliter is equal to 10 to the minus third liters. And so we can convert from a large scale to a small scale and vice versa.